built in the world's most sophisticated factories.
It's a new adventure, and I've been around and I've seen different things, and this is the greatest.
With cutting-edge technology.
It's 20 years beyond what the competitors are doing right now. Sign me up, I want one.
And handcrafted excellence. There's a new wave of cars with cords, built for going the distance and built for speed. SpeedMakers, electric vehicles. Imagine a sports car, rocket fast, 0 to 60 in just 3.7 seconds. A car with racer handling and exotic good looks. Now imagine the car is electric. Meet the Tesla Roadster, part of a new wave of electric vehicles that are revolutionizing the way we think about plug-ins.
The general public will buy electric vehicles in droves when they're actually better than internal combustion engine cars are right now.
And it's all thanks to two key advances: the development of powerful, lightweight lithium-ion batteries and lightweight body structures that reduce weight and power requirements. Technology that just a few years ago would seem impossible.
What we saw was an opportunity using 21st century technology, the environment that we saw in the 21st century, that made it for the first time very viable to have this car possible.
The result? After a century of dominance, gasoline vehicles are getting some serious competition. And leading the charge are three lean, green, electrified machines. The Tesla Roadster, an all-electric exotic sports car. The Chevy Volt, an extended-range economy car that'll take you from San Diego to Las Vegas without a fill-up. And the Jaguar CX-75, an 800-horsepower supercar that tops 200 miles an hour. To build these radical machines, you need three unique factories. In Detroit, Michigan, GM engineers, technicians, and cutting-edge technology build one of the world's most advanced cars on a commercial scale. The Chevy Volt. In Castle Bromwich, England, Jaguar designers are on a mission. Their aim? Create a perfect prototype, then revolutionize the market. But here in Northern California, one small manufacturer has already become the benchmark for electric car excellence: Tesla Motors.
The Tesla brand stands for no compromises between performance and efficiency. And Tesla is the first vehicle and the first brand that lets you have amazing performance, acceleration, handling, but also world-class efficiency, best efficiency of any vehicle in the world.
The company's two-seat Roadster is a trailblazer. 100% electric. It shows that electric cars are viable alternatives to the combustion engine.
Tesla sets itself apart by throwing down the gauntlet on what's possible with the technology. You know, we set out to build a car that wouldn't have a compromise and would beat the best internal combustion engine cars.
This car is 6 times as efficient and emits 1/10 the pollution compared to other sports cars, while producing the same performance. Best of all, there's no range anxiety associated with the Roadster. It'll go 250 miles on a single charge. All for $150. There's no other electric vehicle like it. And what about acceleration? The Roadster is a rocket ride. The torque is completely different from a gas car. Just floor the accelerator and the pushback into your seat is immediate, thanks to instant access to a mighty 300 pound-feet of torque and 288 horsepower.
Being behind the wheel of a Tesla Roadster feels to me like what I imagine being launched off of an aircraft carrier would be.
The source of that power is Tesla's all-electric engine. Little bigger than a watermelon and with only one moving part, this powerhouse is a marvel of modern technology. Here's how it works. AC electric motors are deceptively simple. There are basically two major parts, a rotating part called a rotor and a stationary part called a stator. The interaction of magnetic energy and electric current produces rotational speed. This turns the rotor and drives the transmission. The transmission rotates the axle and propels the wheels. The trick? Building an electric engine that's efficient, durable, and able to propel a 3,000-pound car at sports car speed. The Roadster engine's built at Tesla's Palo Alto facility in Northern California. Here, over 170 designers, engineers, and technicians work to keep Tesla at the forefront of electric vehicle innovation. The heart of the action is the huge 90,000 square foot powertrain manufacturing floor. Unlike a typical high-volume auto plant, where robots assemble the pieces, all the assembly at Tesla is done by humans. The engine build starts with this, a low-resistance copper rotor. Tesla technician Kevin Stewart places the raw part into a computer-controlled grinder. Its job? Grind the exterior until it's perfectly concentric. The reason? Speed. Inside the stator, the rotator spins at 14,000 RPMs. At this speed, the slightest imperfection will cause the rotor to vibrate and break. Water keeps the copper surface cool, as the grinding stone removes any excess material. Throughout the process, Kevin checks the rotor's measurements and adjusts the computer's program accordingly. The job's done. Next, paint the rotor red. The red paint makes it clear if the rotor is rubbing against anything when it spins. Finally, the rotor is balanced to ensure that both sides of the rotor are spinning at equal rates. Now, it's time for the rotor to meet the stator. A series of copper coils winding through a stack of steel plates called laminations. These copper coils conduct the electricity through the motor. Tesla uses a top-secret winding pattern to optimize efficiency and power. Once the rotor and stator meet, they're officially branded a Tesla motor.
Here you have a final completed motor, and one of the amazing things is even though this is about a 300 horsepower electric motor, you can still reach up to it and spin it with 2 fingers. You could never do this with an internal combustion engine. There'd be far too much drag.
There is debate over who came up with the first electric vehicle, but around the turn of the 20th century, there were more electric cars than gasoline cars. Early EVs included the Baker 1902, the 1918 Detroit, and a Belgian torpedo-shaped car called the Jamais Content, which raced at over 60 miles an hour. In the 1920s, the EV went into decline, thanks to the rise of cheaper gas and the need for longer-range vehicles to cover America's vast road systems. Production electric vehicles didn't re-emerge until the early 1990s, when GM developed the Chevy S10 electric pickup and the controversial EV1 coupe. The EV1 was the first mass-produced electric vehicle of the modern era from a major automaker. But unhappy with the EV1's profitability and performance, GM destroyed almost all of the prototypes. It wasn't until the Tesla Roadster came along in 2008 that the electric car re-emerged as a viable production option for auto manufacturers.
What we tried to do with the Roadster is offer a car that was comparable to the best supercars in the world, offered at a radically lower price point, and with the added benefit of the fact that the car has no tailpipe and 0 emissions. Everyone told us it couldn't be done. 2 years later, here we are.
Back on the Tesla powertrain line, the technicians prep the gears by grinding and cleaning them for a proper fit in the transmission. Further down the line, they merge the motor and transmission. After a thorough inspection, the unit is packed and ready to meet the Tesla body. Here at Tesla's powertrain facility in Palo Alto, California, technicians assemble the revolutionary Tesla battery pack, or energy storage system. Much of the area and process is top secret. Few cameras have been allowed in. The reason? No other manufacturer has developed a battery pack as powerful as this. Rated at 53 kilowatts, there's enough juice in each pack to power an average US home for 2 days. On the road, all that power equals range. A Roadster can go up to 245 miles without a charge, a distance unmatched by any other electric car manufacturer. The battery pack's exterior arrives at the factory as a prefabricated shell. It takes 30 factory technicians a full week to build 18 packs. A single pack's made up of 11 separate modules, each filled with 621 lithium-ion cells, similar to the ones found in your cell phone. Altogether, that's an amazing 6,831 individual batteries. How they're crammed into the modules is proprietary, but once complete, this beast weighs over 900 pounds. An associate hoists the finished pack onto a wooden plate and bolts it down. Next stop, the Tesla's final assembly workshop in Menlo Park, California. Roadster bodies arrive at Tesla's final assembly workshop already fabricated. Called a monocoque, they're a carbon fiber single shell, which keeps the car extremely rigid and lightweight. The aluminum chassis also keeps the car weight low.
Using an aluminum chassis, a carbon fiber body, very lightweight interior materials was critical to maintaining a very high range and also fast acceleration.
To begin, the team mounts the motor unit on a harness and swings it into position. Next, the lithium battery pack. The nearly 1,000-pound module sits on a custom-built cart. An associate rolls the pack under the suspended Roadster. And now the challenge begins. The team hoists the pack inches at a time to ensure it's in the right position. It's a tight fit. Next, they add high-voltage cables for charging the motor. The two technicians work in sync, side by side. In this confined area, they never get in each other's way, thanks to 2 years of working together 9 to 5. The battery pack should last at least 100,000 miles, or about 7 years. Next, in goes the rear suspension. Cooling fans are installed for the motor and power module. Bolts to the underframe hold it all in. Next, they pump in automatic transmission fluid. A quality control inspector reviews the work before the underbody is closed up entirely. Next, the body is lowered to gain access to the rear compartment. The technicians add the brains of the Tesla, the PEM, or Power Electronics Module. The PEM interprets the accelerator pedal input and sends the right amount of alternating current to the stator. Torque is created in the motor and the car accelerates.
The Tesla Roadster is an incredibly green vehicle. It, first of all, doesn't use any petroleum at all. The vehicle is only powered by electricity by recharging it. So it's not a hybrid, it's 100% electric. And in terms of just efficiency, it's about 2 to 3 times as efficient as a Prius.
Now they connect all of the power cables to the motor. The addition of liquid coolant chills the battery's lithium-ion cells, which can heat up much like your laptop. Then they add a service disconnect, which completes the circuit in the battery. This will allow the battery to turn on. Now, the marriage of the body and powertrain is complete. But the Roadster needs 4 more components before it can hit the road. The wheels. Now, the Tesla Roadster is done. The technicians lower it to the ground and charge it for the first time. Charging is simple. Just plug the car into a socket. Charging takes as little as 4 hours if you use a 220-volt outlet, like the one for your stove, and a proprietary quick charger sold by Tesla. Without the quick charger, it'll take 8 hours. This car is ready to impress a Ferrari. At the end of the day, 3 Teslas will leave the factory and meet their customers. Each will cost a little over $100,000. But if you think that's a little steep, Tesla has a new car in the works. The next generation of Tesla will soon hit the road, the Tesla Model S, slated for mid-2012. It's a daily driver with a 300-mile range, and it's being called the first premium all-electric sedan.
A lot of people assume wrongly that the objective of Tesla and what we're trying to do here is build a supercar for a limited number of buyers. That's actually not what we're trying to do. Tesla's objective ultimately is to build affordable electric vehicles for the masses.
With the Roadster and the Model S, Tesla is leading the way to a revolution. But the competition is getting fierce. With its superpower and exotic looks, the Tesla Roadster has made the electric car an object of lust. Now, another revolutionary electric vehicle is turning heads for its technology as well as its price. General Motors has spent 3 years and over $1 billion developing the Chevy Volt, an electric hybrid compact.
The Chevy Volt is really a technological marvel. It's the first electric vehicle that we feel can be used as a mass market product. You can do anything a regular car can do just with the power of the electric motor, always driven electrically, and that's the way the Chevrolet Volt operates.
The Volt can travel up to 50 miles on electricity from a single battery charge and can extend its overall range to 379 miles with its flexible, fuel-powered engine. Here's how it works. The Chevy Volt has 2 motors, a battery-powered motor and a gas motor. How it sets itself apart from other hybrids? The gas engine only acts as a generator. Its sole job is creating electricity to recharge the Volt's batteries. This sets it apart from its competitors, which use gasoline and electric motors to power the wheels. This means that if you drive less than 35 miles a day in your Volt, you'll never have to use a drop of gasoline.
We had to do some significant technological innovation. We had to create a new battery, a new car, sophisticated software, and a lot of infrastructure to bring it all together and allow customers to plug right in.
And speed? The Volt is no slouch. 0 to 60 miles per hour in 9 seconds. But it's incredibly quiet, even when the gas engine kicks in.
One of the nice things is you're in a vehicle that's virtually silent and the thing goes 100 miles an hour and you can't hear a thing while you're doing it.
And this ride has a major cool factor. It beat the likes of Infiniti, Corvette, and the Prius to win Motor Trend's Car of the Year.
I was so pleasantly surprised with the instant torque on this vehicle and how quick it really is. I think it's going to absolutely astonish people that buy the vehicle.
One look, and you can see the exterior is designed for aerodynamic efficiency. The sharp rear corners and the integrated spoiler are all about managing the airflow at the rear of the car.
Aerodynamics becomes really important on an electric vehicle like the Chevy Volt. If you can make it aerodynamic, meaning that it can cut through the air a lot easier, then your battery will last a lot longer, and that translates to a longer range.
The Volt is a little more conventional looking than earlier prototypes, all because Chevy continued to improve on its aerodynamic design.
If you think about aerodynamics, good sound aerodynamic principles are that you want to keep the air attached to the shape. You don't want the air to separate and become turbulent, because turbulence creates drag. So if you look at the front of the car, the shapes in plan view, looking down, and in side view are all very smooth, all in an effort to keep that air attached to the car.
The first Volt debuted in early 2007 at the Detroit Auto Show. For nearly 2 years, engineers refined the design. And by late 2008, the production car was ready.
It's now my great pleasure to present to you the production version of the Chevrolet Volt.
While the exterior evolved into a classic compact design, the interior maintains the radical looks of the prototype. Squint, and you'd think the interior was modeled after an iPod. GM plans to build 10,000 Volts this year, and they'll all come out of its Detroit Hamtramck factory. Our cameras are capturing the first production run of Volts ever to be manufactured. The Volts are built alongside Cadillacs and Buicks on an assembly line that stretches 24 miles and covers 3.6 million square feet. The area could hold more than 60 football fields. Here, hand-tooled craftsmanship and high-tech robots coexist on the factory floor. It all starts in the body shop. Body panels and parts arrive from the stamping shops in Flint and Lansing. While there are only 1,000 workers on the general assembly line, the body is built almost entirely by robots. To begin, a conveyor moves a unibody into the robotic framing area. First, the framer uses clamps with electrodes to concentrate welding current into a small spot. Its job? Spot weld all the parts of the unibody together. Next, a densely packed group of robots join the action. These 6-axis robots can rotate, extend, lower, raise, twist, and tilt each head to hit the exact spot. Their job? Add additional welds to make the unibody super strong. This station of robots can make 285 spot welds in just 50 seconds. Because electric cars operate in near silence, the extensive welding eliminates unwanted squeaks or rattles. These sounds would normally be masked by the vibration of a gasoline combustion engine. Next, the finished unibody is measured for dimensional accuracy. After the doors and hood are added, metal workers inspect each newly assembled unibody for dings, dents, and other imperfections in the metalwork.
Any defects coming down on a car, you have to make sure it's good quality for a paint shop.
Any flaw will compromise the integrity of the paint job and require a complete repaint. So the workers sand, buff, and polish until the body is super smooth.
Looks like a Volt.
Next, the body heads to the paint shop. First, the car needs corrosion protection. This is where the electrostatic coat, or E-coat, comes in. The conveyor submerges the body in a deep tank filled with the E-coat paint. Next, a surge of electrical current rolls through the liquid. This charges the paint positive. The volt is grounded by the conveyor, giving it a negative charge. As a result, the E-coat paint is magnetically attracted to every crevice of the body. After a few minutes, the body emerges, looking a dull shade of gray. It heads to an oven for drying before it gets its next coat. After the E-coat process, robots add sealant around the gaps. A tight seal insulates the car against wind and sound. Next comes the primer and base coat, and the true color of the Volt emerges. When it's done, technicians buff and smooth any imperfections in the finish. Then, quality control steps in and scrutinizes the paint job. After 3 days of curing and coating, the Volt body is ready for the next phase of production. The Chevy Volt isn't exactly an economy car. The base price is just over $33,000, if you include the $7,500 tax credit from the government. But still, the Chevy Volt is reinvigorating General Motors. So much so that the factory has sparked recognition from the White House.
And by the way, these aren't just any jobs. These are jobs in the industries of the future.
The Volt is generating newfound interest in GM cars and at the same time creating an entirely new segment of the American auto industry. It takes more than 1,500 components to build a Volt, and they arrive at the factory from around the world. Now that the painted body has reached the final assembly line, 1,000 employees will assemble the rest of the car in a span of just 20 hours. They have just 107 seconds to complete each cycle, and that requires special training.
We have a great deal, a high amount of people that are responsible to put this car together. It takes a lot of people to do so. So we came up with a very detailed training process for each of those people to include thousands of training documents. Each component of the Volt has a specific training document that says to the operator, this is exactly the way you put this vehicle together, how you do it, and why you do it that way.
The body shells ride on height-adjustable conveyors. That way, the workers can access whatever part of the car they need.
So there are different levels of conveyor on the line specifically to address ergonomic and build concerns, to make sure that our operators are building safely and they can come home from work every day the same way they came to work, which is healthy.
First up, the workers remove the driver's doors to facilitate installation of the charging port, dashboard, and interior. Door removal makes it easier to install the interior without damaging anything. The doors are labeled and ride next to the cars on the perimeter of the floor so that technicians can find them again. Next, a technician installs a wiring harness. It's a protective bundle shielding delicate wiring from the elements. It's also designed to optimize the use of space. This harness will transport power to all of the electrical systems in the car: motor, speakers, and dashboard. Further down, the technicians install the instrument panel. It's a single unit that contains the gauges, stereo, HVAC controls, the steering column, and the pedal assembly. It slides into the car on a robotic arm with one person on each side to bolt it down. The instrument panel includes an LCD screen. The screen clearly illustrates how many more miles you'll get out of the battery, and then, once the battery's exhausted, out of the gas generator.
Stereo controls and your nav system is all controlled on here, very much like an MP3 player. So you'll see a combination between familiar styling elements and functional elements, and just enough newness so people realize that technology is at the core of this vehicle.
A plug-in car requires some place to plug it in, and the Volt's charge port is just in front of the driver's door.
The plug itself is common with other electric vehicles on the road, but the port around the outside is styled so that it looks special. It looks something a little bit different, a little bit better than just a fuel door.
The port serves a design function as well as a practical one. It needs to be built tough so it can stand up to regular plugging and unplugging. But it also needs to look slick. Meanwhile, on a sub-assembly line at the Volt factory, workers are building the chassis. Here, they add the exhaust system, front and rear suspension, tie rod, and shocks. The finished chassis travels to meet the Volt's engine generator and electric drive unit. From an overhead conveyor, technicians lower the unit down onto the chassis, forming the Volt powertrain. The Chevy Volt takes the guesswork out of driving an electric car. That's because GM equips the Volt with a small gas-powered generator that can power the electric motor even after the battery's dead.
People don't even know when the battery's depleted and the engine generator seamlessly kicks in, creates additional electricity.
Further down the line, the technician adds the radiator and brakes. The brakes supplement one of the most advanced features of the Volt. The Volt recharges its own battery even when it brakes, thanks to regenerative technology that translates the car's momentum back into electricity as it slows down. Like the Tesla, the Volt converts mechanical energy, the friction from braking, into electrical energy.
And so we have found that we can capture about 70% of the braking energy and push it back into the battery to create greater efficiencies.
Now the finished powertrain and suspension are ready to meet the body. First, the Volt body takes to the air for the installation of the battery and powertrain. It's one of the most exciting moments of the build. Both are installed from the bottom. This is a process that Chevy and many car companies call marriage. The Volt's 16 kilowatt lithium-ion battery packs come from GM's Brownstown assembly plant.
This battery can power a vehicle of the size of the Chevrolet Volt, a compact car, 25 to 50 miles. Could probably power your house for just about half a day. And don't tell your kids this, but it probably could power their cell phones for about 6 or 7 years straight.
Each battery pack uses 288 cells, about the size of a license plate, and takes about 3 hours to build. The battery charges in just 4 hours using a 240-volt recharging stand, or 8 to 10 hours when it's plugged into a regular household outlet. On the assembly line, the battery packs are trucked into place along a guideway buried in the concrete floor. Then the Volt body dips down from the overhead conveyor. The pack weighs over 400 pounds, so workers are assisted by pneumatic hoists to lift the pack up to the chassis. 24 bolts secure everything in place. Further down the line, the 1.4-liter four-cylinder engine in the Volt is mated to the power generator that provides juice when the battery runs down. The engine is made of a cast iron block and an aluminum cylinder head, pistons, and rods. The aluminum keeps the engine weight down to just 240 pounds. The engine generator is moved on an automated cart containing the front subframe and all of the powertrain components. Now, the entire powertrain is ready to meet the body. As the body dips, the powertrain rises and joins the Volt. Now, the car has its superpower. Further down the line, technicians bring in the front end. Now, the Volt gets the Chevy Badge of Honor. Seats go in next. Then, the steering wheel. Now, the interior is complete. The front doors fly in on a pneumatic arm and are returned to their proper place. The Chevy Volt is near completion. It's taken almost 60 hours of building to get to this final stage. At the last station, the wheels roll into place from an overhead conveyor. A pneumatic wrench with 5 sockets simultaneously tightens all the lug nuts to the proper torque. The wheels are another innovation on this groundbreaking car. They're made of forged aluminum to reduce weight.
They're some of the lightest 17-inch wheels in the industry. They're just over 7 kilograms. Forgings tend to be very strong and very lightweight, which is consistent with the car. We also designed the face of the wheel to minimize the pumping action of air from inside the car out.
The car stands on its own for the first time. Once a car rolls off the line, the technicians align and balance the wheels and check the controls. Then, it's off to the roll test, where the car is accelerated to 70 miles per hour on what amounts to a giant treadmill. Finally, under bright lights, every car is thoroughly checked for fit and finish before leaving the factory.
We do a visual check of everything consists of the Volt, as far as electrical, mechanical, engine, paint, everything.
Then, the completed Volt hits the asphalt. There, it will get its first charge and head to what GM calls the squeak and rattle track. The track is peppered with cobblestones, rumble strips, bumps, and torsion twists, all to test the body's performance.
This is very important to squeak and rattle because you send this car out with a loose bolt, a loose screw, a product that's non-conforming, and it could go against our quality down the road and people would not want to buy a car like this. This instills that it's 100% good.
Once the Volt passes the test, it's driven into a giant parking lot to await shipment. These are the first shipments of production Volts ever to leave a GM plant. They'll head to East Coast dealers and ultimately to initial launch markets in Texas and California. GM plans to quickly increase production on this car thanks to its highly efficient assembly line.
I really enjoy working with the Volt. I think it's the #1 Chevy vehicle on the planet.
We're trying to make sure we bring GM back where we're supposed to be, at the top.
Workers on the Volt line are proud to be building a car of the future today. The race to produce the best electric vehicle is far from over. There's another electric vehicle in the works. And this one will convert the most die-hard combustion junkie. For its 75th anniversary, Jaguar has unveiled the CX-75, a range-extended electric supercar.
A car with a maximum speed of more than 330 kilometers an hour, the CX-75.
I think the CX-75 is an absolutely groundbreaking vehicle. The technology, the styling, the innovation, and maybe most importantly for an electric hybrid vehicle, the performance. You actually want to drive the thing because it's really going to be fun to drive.
The CX-75 unleashes some major thrust. It roars from 0 to 60 miles per hour in just 3.4 seconds. How does it do it? 4 powerful 195 horsepower electric motors, one for each wheel. Together, the system produces almost 800 horsepower and a whopping 1,180 pound-feet of torque. And if an engine for each wheel isn't groundbreaking enough, check out what's in back. 2 turbine blade engines, similar to the ones used on airplanes, only miniaturized. Fueled by gas, these powerhouses act as generators, They recharge the CX-75's lithium-ion batteries and drive the electric motors.
These are quite special. They're axial flow microgas turbines, that's the first. No one's done that before.
The advantage? Turbine engines require fewer parts, can run on a variety of fuels, including natural gas and biofuels, and are a low-emission power source. Together with heart-stopping speed, the CX-75 achieves impressive range. 68 miles on electric juice and over 500 miles when the electric portion of the powertrain works in sync with the twin gas turbines. But don't look for it at your neighborhood Jag showroom. For now, this four-wheeled object of desire is just a concept car. But who knows for how long? Jaguar has just bought shares in a gas turbine manufacturer. It looks like they're taking the future of this technology seriously. Automakers are starting to put their might behind the electric car. Even the most legendary companies are plugging into the revolution. For 75 years, Jaguar has epitomized the highs and lows of Britain's auto industry. At its best, the company was characterized by Le Mans winning sports cars and head-turning design. At its worst, Jaguar suffered a reputation for stodginess and questionable reliability. With the CX-75, Jaguar is becoming a leader in technology and innovation. Again.
In a Jaguar's case, we cannot compromise on our attributes of performance. We have to create something that still maintains Jaguar attributes. It still has to be beautiful, it still has to be quick.
The CX-75's design and technologies could catapult Jaguar for another 75 years.
The CX-75 isn't just something that is matching what the competitors are doing right now. It's 20 years beyond. It's absolutely groundbreaking technology. They wrap that in a gorgeous Jag design and give it performance that'll beat the fastest road car on the road today, the Bugatti Veyron.
For Jaguar and many other automakers, electric cars are helping to reinvent their brand.
It's inevitable that more and more cars will become electric powered because the immediate emissions from that car can be zero.
The cars of the future are here now. They're electric and faster for it. Built for sustainability, built for the everyday driver, and built for speed.